Hello, everyone. I would like to dedicate today entirely to circuits. There is no unit that I get to dedicate entirely to circuits, but since we use electrical components every day on a day-to-day basis, I think it's important that we understand a little bit of how circuitry works and how everything is connected. So you have two types of circuits. Let's start there. You have two types of circuits. You have a series circuit and you have a parallel circuit. Okay. In a series circuit, as the name implies, you have everything connected in order, in series. You have one solid connection, one solid loop. Okay, you have one single loop. Okay, that is a series circuit. And a parallel circuit, you have multiple paths that things can take. Okay, multiple paths that things can take. And the advantage of parallel is that you can isolate certain things. And we'll get to that in a second. First, let's talk about how voltage and things like that are affected by the different types. So, in every circuit, you need a power supply and you need something to consume the power. Okay, you need something to slow things down. Okay, in this case, we have a resistor. Okay, so let's say I remove the resistor. If there is nothing to consume the power, you will cause a fire. The reason you will cause a fire is because you will get this infinite flow with nothing slowing it down. Okay, and with nothing slowing it down, you get too much friction. Don't think just because electrons are tiny that they can't produce friction. Okay, and you guys have used laptops and batteries and things like that, and they overheat after a while. Okay, so if you have nothing to consume the power or slow it down, you will cause a fire. Okay, and everything that consumes power can be considered a type of resistor. So a resistor is just serves no purpose other than to slow it down, resist, as the name implies. But everything that consumes power, like a light bulb, if I put a light bulb in here, a light bulb would also behave as a resistor because it's consuming power. Okay. So resistors alone in general are just used to control flow. Okay. So you put the resistor in and now the flow starts to slow down, you can control it. Okay. If I decrease the resistance, you get more flow. Makes sense. If I increase resistance, you get less flow. Okay, that makes sense. Voltage. Voltage is the other component. You have current, you have resistance, you have voltage. Voltage, think of that as the potential energy inside each electron. Okay? So think of the battery as the home. When the electron leaves the home, it has a certain amount of energy. This thing right here is called a voltmeter. A voltmeter works by measuring potential difference. Okay? It measures a difference. So notice here, I'm getting 0 volts. The reason I'm getting 0 volts is because every electron here has the same amount of energy because they just left the house. There is no difference. Okay, they all have the same energy. However, if I measure it over here, think of the resistor as a factory. You go in the factory, you work, you get tired, you come out tired. Okay, notice how here now it says I have 9 volts. That's because the difference in the energy before and after they go in is 9 volts, as the battery implies. The battery is 9 volts. If I increase the voltage, notice the voltmeter goes higher. Okay. So that's how you measure voltage, and that's how resistance affects flow. Okay. If I increase resistance, notice how my voltage is not affected. Less flow does not equal less energy. Okay, I repeat, less flow does not equal less potential energy. Okay, so just because you reduce the flow doesn't mean you reduce the amount of energy each individual electron has. Okay, think of it in terms of mass and force. Okay, just because something is smaller doesn't mean it's going to have less force. Okay, for example, a bullet. Bullets are tiny, but because they go super fast, they have a lot of force. And a boulder is huge. A boulder is huge. It weighs a lot, so it can go slower and still have the same amount of force. Okay, so speed, flow, current, these things do not affect the amount of energy something may have. Okay, think about it like that. Okay, so resistance has no effect on voltage. I just wanted to make that clear. Resistance has zero effect on voltage. Okay, it affects current, but not voltage. So now, let's go back to parallel. So I said the advantage of parallel is that you can isolate things. I want you to think of a parallel circuit as a bunch of series circuits linked together, okay? So in this case, we have two individual series circuits connected, okay? I have the top series circuit, okay, the top half, and I have the bottom series circuit, okay? Everything is connected to this home battery, okay? So this middle piece is one, and then the whole outer loop is another one, okay? The bottom half is not considered a series circuit, okay? Notice, look at the flow. Where's the flow going? The flow is going from the butt end of the top battery, and this is where it's splitting. It's either going through the middle or towards the bottom. So the outer loop is one circuit, one series circuit, and then the inner loop is another series circuit, okay? So we have two series circuits here. Okay. In a series circuit, if you connect two batteries together, the voltage is going to be equal to the sum of the voltages, okay? So look at my voltmeter. My voltmeter here is reading 18. That's because I have two 9-volt batteries. So now instead of home base, think of the batteries as a charging station. So the electrons are going through two charging stations. They're going through two 9-volt charging stations. So when they're done, they're going to have 18 volts, which is exactly what they have. So in here, in the top series circuit, I have a battery here and I have another one here, okay? So I'm going to show you something real quick. So from here to here, notice how it says 9 volts. It says 9 volts because at this point, the electrons have only gone through one charging station. But if I measure the voltage from here, notice how it's 18. It's 18 because now it's gone through two charging stations, okay? It's gone from this top battery once, and then it passes this second one again, and now it has 18 volts, okay? So this is the top series circuit only. Look what happens when I measure the voltage down here at the bottom. It's only 9. It's only 9 because the electrons that are taking this path, the bottom path, only go through one single battery. So this is what I mean when I say you can isolate things. So even though they're all connected, everything here is connected, the bottom portion is not affected by the middle portion at all, okay? I can do whatever I want in this middle piece and it won't affect the bottom piece, okay? So what parallel circuits let you do is they let you connect things and manage them independently. So even though they're connected to the same power supply, I can individually control what happens in each path, okay? And that's needed if you want to connect different things, okay? Let's say I want to connect a light bulb here, but I want to connect the computer here, okay? They're going to need different things, okay? And so you can affect the current and the voltage. The computer is going to need more power. So let's say I add a second power supply, but I don't want to affect the other one. That's when you would use a parallel, okay? So if I change the resistance here, I'm affecting the current down here, but I'm not affecting the top one whatsoever, okay? So that's the difference between parallel and series, okay? In a parallel, everything, you still have the series component, because this is what I mean by combining both. Think of them as individual series connected. You still have the series component. I have two batteries here, so the voltages add up. But the current and the everything else and the bottom piece is completely unaffected, okay? So that's the difference between parallel and series. Some other things I want to talk about. You guys all know that you should not stick a fork in an outlet. Why? Why is that a bad idea? It's a bad idea because you're going to get shocked. But why do you get shocked? Why does that happen? That happens because you're giving the electrons a shorter path to their destination, okay? If you had the option, let's say you were walking down the road. If you had the option to choose the bumpy road or the smooth road, which would you take? you're going to take the smooth road. So if I give the electrons the option to either go through the resistor or to not go through the resistor, they're not going to go through the resistor. What I did here was I created a short circuit. I gave the electrons a shorter path to a shorter and easier path to their destination, okay? And when I did that, I created a short circuit and I caused a fire. So that's what a short circuit is. I'm sure you've heard that term before, but all it means is that you created a shorter path for the electrons to take, okay? And that can be dangerous because it affects everything in the system, okay? It affects every single little thing in the system. Okay, let's say I do the same thing here. So instead of the electrons having to go through all this, I can skip this entire thing and just have it go through the top piece. I created a short circuit and that caused a fire. Okay, you can cause things to overheat. That's what a short circuit is. Okay, so to summarize, you have two types of circuits, series and parallel. In series, the thing you can take advantage of is adding batteries. The more batteries you add, the more power you can get. So instead of having to buy, let's say you need 120 volts, instead of having to buy a whole 120 volt thing, you can connect multiple smaller batteries in series and that'll increase the voltage, okay? But let's say you want to independently control something else, you want to connect multiple things that have different amounts of power requirements, that's where you take advantage of parallel, okay? Parallel allows you to connect certain things while independently managing other paths, okay? So the paths are independent and you can control what happens in each individual path separately, okay? That's the main difference between series and parallel, okay? Where are we on time? Okay. And that's, I think I'm gonna wrap it up here. I was trying to do something where I demoed with the hand, but the simulation wasn't working out too much, so we're gonna leave that be. Yeah, the short circuit piece, sticking the fork in the outlet, things like that. The reason you get shocked is because you're creating a shorter path for the electrons. Okay, I had to pause it for a second. I had to go do something. But yeah, I think I'm gonna wrap it up here. I want you guys to, if you finish, continue playing around with it. All of you haven't submitted your circuits. Okay, when you get a chance, please do that for me. I want you to continue playing around with this and see what happens with the different voltages and things. Okay, I'm going to try to get a mini lab at some point. Try to. We'll see. I'm trying to come up with ways to do these things. But wish you all the best. Take care, be safe, and enjoy the rest of your day.